Find the area bounded by y equals to x squared minus 5x and y equals to 25 minus x squared. So let's take a look of the first curve. Both of these equations are quadratic. We have y equals to x squared minus 5x. Our coefficient of x squared is positive, then we're going to get a smile graph. Now let's find the intercept. So when x equals to 0, we're going to find the y-intercept. So substitute 0 into our equation or into our function. So 0 here and 0 here, then we're going to get y equals to 0. So the y-intercept is 0. And if our y equals to 0, x squared minus 5x equals to 0. Factorize x and x times with x minus 5 equals to 0. We're going to get x equals to 0 and x equals to 5. So these are the x-intercept. Now let's take a look at the second curve, which is y equals to 25 minus x squared. So let's take a look at the basic shape of our graph. The a or the coefficient of x squared is negative, and it's going to be a set graph. Let's find the intercept. So when x equals to 0, the y-intercept is 25. Put 0 here. And if y equals to 0, then 25 minus x squared equals to 0, and x equals to plus minus 5. These are the x-intercept. Now let us sketch our graph. The y-axis, the x-axis, the origins. So let's take a look at the first curve. So we're going to get a small graph. The graph must cross the origins. And the x-intercept is 0, and also x equals to 5. So we're going to get a small graph. So these are y equals to x squared minus 5x. Now let's sketch the second curve, which is 25 minus x squared. So we're going to get a set graph. When x equals to 0, y is 25. So let's say this is 25. And our x-intercepts are negative 5 and 5. So let's put negative 5 here. And it's also going to cross this 5. So let us sketch. So these are y equals to 25 minus x squared. Now, to find the shaded region, these area must be enclosed by the two curves. So this is easily can be guessed. And the area is in the middle of these two curves. So these are the shaded region. Okay, now let's find the area. Just before we find the area, we need to determine the limits. So we have the upper limit, which is 5, but we don't have the lower limit. So to find the lower limits, we need to find intersection, because there is a point that intersect at these two curves. So to find the points, we need to equalize these two functions. So we have x squared minus 5x equals to 25 minus x squared. Bring it whatever on the right hand side to the left hand side. So we have 2x squared minus 5x minus 25 equals to 0. Then if we factorize, we're going to get 2x plus 5 times x minus 5 equals to 0, and x equals to negative 5 over 2, or negative 2.5, and x equals to 5. So x equals to 5, this is where the two lines intersect, and x equals to negative 2.5 is a bit here. This is negative 2.5. So we have the lower limits now. Now let's find the area. So area is, we're going to integrate from negative 2.5 until 5. And if you can see here, the above limit will be the blue lines here, which is 25 minus x squared, because it has larger area, the whole thing under the curve, the whole area under the curve. Okay, and it will minus with this one, the below limit, the below curve here, because the area under the curve is smaller. So we're going to minus with x squared minus 5x. So when we do so, we're going to have a positive area. So make sure we take the above curve minus with the below curve. So let us simplify first before we integrate. 25 minus x squared minus 5x is 25. Negative x squared minus x squared is negative 2x squared. Negative times with negative 5x, we're going to get positive 5x. Now let's integrate our function with respect to x from negative 2.5 until 5. And we're going to get 25x minus 2x cubed over 3 plus 5x squared over 2. Now we're going to substitute the upper limits, and we're going to minus with the lower limits. So let us substitute now. So 25 times 5 minus 2, 5 cubed over 3 plus 5, 5 squared over 2. So this is the substitution of the upper limit minus with the lower limit. Let us substitute. So 25 times negative 2.5 minus 2x cubed times negative 2.5 over with 3 plus 5 negative 2.5 square over with 2. Now, if we substitute into the function, we're going to get 1125 over 8 unit square. So press the calculator to find this value, okay? So that's it, how we find the area of this shaded region.